Hello students, welcome to online classes of Geography of class 11. This is my first class of your chapter number 2, Structure and Physiography of India. Now hopefully it will be very interesting to know about the topics that I am going to discuss today, because I'll discuss about the evolution of our own country, that is evolution of India, then formation of the three major geological divisions, that is Peninsular Block, Himalayan Mountains, Indo-Ganga Brahmaputra Plain, and what are the resultant or what are the basic forces that is activating. So we will discuss about the forces that is basically activating to create all these geological divisions of India. So now let us proceed to the first topic, that is I have started with a topic that is geological cycle. Now you hopefully have heard about hydrological cycle or other types of the cycles, but now it is related to the geological cycle. Now geological cycle is a balance between two forces. One is endogenic force and another one is exogenic force. Endo means interior, exo means exterior. Now the interior is basically doing the work of building, and exterior is doing the work of wearing down, that means continuously lowering down. So there is a balance between these two forces, and when the balance is there, and it is an interaction between the three cycles. One is hydrological cycle, another one is tectonic cycle, and the third one is the rock cycle. Hydrological cycle is there on this surface, tectonic is there in this part, and the rock cycle is there in this part. You can see it is a interaction between the three: hydrological cycle, tectonic cycle, and the rock cycle. Now how is it possible? Let me just explain. First I am proceeding with it. You can see this is a picture of a molten magma that is ejecting out. So when it is ejecting out, it is tectonic one. It is the molten magma that is ejecting out. It's a tectonic part. And when this molten magma is ejecting out on the oceanic crust, what is the resultant? It is resultant to the sea floor spreading. It is moving apart, it is diverging apart, it is sea floor spreading. Now the sea floor spreading is basically creating a gap, and over there the water is being filled up. So we are getting the that is the origin of the ocean and the seas. Now after the development of the ocean and the seas, what is the resultant? Due to this solar energy and due to the high rate of evaporation, the resultant by the process of condensation, we are able to create this entire cycle of hydrologic cycle. Now when this hydrologic cycle is there, we got the next, that is rock cycle. Now the rock cycle is related to, again it is connected with the tectonic cycle. Why? Because due to the tectonic cycle, the endogenic forces that is leading to the ejection of the molten material to the crustal part, it is there to form the rock, primary rock, that is the igneous rock. Now the igneous rock, after it is formed, it is considered as a parent rock. Then due to the exogenic forces, we are able to get the another set of rock, that is sedimentary rocks, and again due to endogenic forces we are able to get a third set of rock, that is metamorphic rock. So what is it? We are getting the rock cycle, tectonic cycle, and hydrological cycle. When all these three cycles are interacting with each other, we are able to get the various types of landforms on the earth's surface, and it is termed as geological cycle. Now next I will proceed with the topic that the two main system or the forces that is continuously activating simultaneously, and it is leading to the development of the landforms. Either it is creating or either it is lowering it down. Now, the first one is the exogenic system or the exogenic forces that is activating from the external part of the earth. And basically the source of energy is insolation or solar radiation, and this energy is transmitted to air, water and ice. And again one more force, that is due to the influence of gravity. They are continuously creating the motion for all these that is the masses or the agents that is helping to create the exogenic system. And the best example is the hydrological cycle. And the next force that is activating on the earth's surface, that is the internal force, which is termed as endogenic force, and it is basically due to the resultant of the earth's internal heat and pressure. And the another one is radioactive decay. Now, what is radioactive decay? Now, the radioactive decay is basically the disintegration. It is basically due to the three radioactive rays. It is due to the three radioactive rays. Hopefully you know what are the radioactive rays: alpha, beta and gamma. Now, these three radioactive rays continuously activate on the unstable nucleus which is present within the earth's interior, unstable nucleus. Now, when it is activating on the unstable nucleus, what is the resultant? The resultant is disintegration of this unstable nucleus, disintegration of this unstable nucleus. Now, when this unstable nucleus is disintegrated, what is the resultant? It is generation of heat, because there is friction. It is generation of heat, and due to this friction, the heat that is generated, it is able to maintain the earth's interior heat. This is termed as radioactive decay. This is termed as radioactive decay. It is termed as radioactive decay. So, hopefully it is clear. Due to the radioactive rays, when it is activating on the unstable nucleus, it disintegrates, and when it disintegrates, it creates friction. When it creates friction, it generates heat, and this heat is basically the source to maintain the earth's interior heat, and this is termed as radioactive decay. So, hopefully what is radioactive decay, it is clear to each and every student. Now, due to this earth's interior heat or endogenic forces, what are the things that has been developed, or what are the features that is developed on the earth's surface? We are getting fractures, we are getting mountains, we are getting volcanic eruptions and the earthquakes. So, example is tectonic cycle. So, these are the two forces. Now, one cycle is missed out over here, that is rock cycle. Now, rock cycle, the first rock that is formed, it is due to tectonic cycle, that is igneous. The another rock that is formed, it is due to exogenic system, that is sedimentary rock, and metamorphic rock is again due to endogenic forces or system. So, rock cycle is activating with the combination of both the system, that is exogenic and endogenic. Now, let us proceed to the next part of the chapter or the topic, that is evolution of India. Now, what is the age of our earth? The age of our earth is approximately 460 million. Now, when the 460 million years of old, that means earlier it was a united landmass and it was continuously activated by these two forces to give a shape to the present structure. Now, what are those two forces that I discussed? Endogenic and exogenic. Now, what is that one united landmass named as? Pangaea. It was named as Pangaea. It was named as Pangaea. Now Pangaea split up into Angara land or Laurasia, which is the present northern part, and Gondwana land, which is the present southern part. That means southern hemisphere and the northern hemisphere. And where India lies now? India is a part of Gondwana land. Now you will say, when India is a part of Gondwana land, but India does not lies in the southern hemisphere. We have already studied about the location of India in the previous chapter, that its location is there in the northern hemisphere. Then how is it possible? When it is a part of Gondwana land, then how it comes to the part of northern hemisphere? Now quickly let's look into this matter. Now just see this entire picture of that united landmass. You can see all the present continents of our present world, it's attached with each other. There is no gap in between. Eurasia, North America, South America, Africa, Antarctica, India, Australia, all were united with each other, named as supercontinent Pangaea. But due to the endogenic forces, what is the resultant? It splits up into two. Number one, Laurasia. Number two, Gondwana. Gondwana means the southern hemisphere. India is still there in the part of southern hemisphere. Now, just let us look into the stages of the splitting of the Pangaea. Now, this is the first part, that is nearly 250 million years ago. This was the scenario of the entire supercontinent Pangaea. Now 200 million years ago, the force that started activating, what is the resultant? You can see the developed gaps. They have developed gaps in between, and the water body that is surrounding this Pangaea was named as Panthalassa. Was named as Panthalassa. So what is the resultant? The gap in between is filled up by the water of Panthalassa. So this was 200 million years ago. Now nearly 140 million years ago, the gap between the land masses increased more. You can see the gap has increased more, and you can see this is India, which was attached. Now India got detached from Africa, but both the that is America and Eurasia is attached, South America, Africa is attached, and India, what is the location of India? Here it is equator, so it is still there in southern hemisphere, and this is 140 million years ago. Now next you can see it is just 65 million years ago. India is still below equator. It is still below equator. That means it is still there in the southern hemisphere. It's still there in southern hemisphere. And South America got detached from Africa. Still the America and Eurasia is still having a connectivity, and here this is Australia actually, and Antarctica is still attached, and this is Madagascar. You can see it's only India, there is no Sri Lanka over here, but from here only one landmass will get detached, and there also a landmass, and then this part here we will get the formation of Sri Lanka. So this is 65 million years ago. Now just look at the present day scenario. So what is the present day scenario? It is Antarctica is over here, we got Australia and a part got detached, New Zealand, this is Madagascar. Now earlier you can see both the Americas were separate, but here you can see both the Americas is now attached with each other. This is the isthmus path, that is a narrow neck like structure joining North America and South America. Africa, now Africa is attached with this part of Eurasia, means Asia part, and sorry, not Eurasia, Asia, and it got detached with Europe. This is Europe, but India is attached with Asia, and here we are having a small island, that is Sri Lanka. So, this is the present picture. Now, just see the next way part. When India, it is 71 million years ago, when India got detached from Africa. The two land masses got detached. One is named presently Sri Lanka, and this is the Indian landmass. Then 65 million. So, what is its location? Southern hemisphere. Why? Because it is below equator. Then 65 million years ago, 65 million years ago, it is again below over here, and it is there below, that is, it is still in that southern hemisphere. It is actually 55 million years ago, it is southern hemisphere, and the location is 55° south latitude. 65 million years ago, the southern hemisphere location, it was 55° south latitude. Now, what does this indicate? That continuously the endogenic force or endogenic force is activating, or the plates are moving, Indian plate is moving, and gradually nearly 20 million years ago, the southern part of our country is still below the equator, and it is bit the, that is the central island part of India, it's still there, it's went above the equator, and 10 million years ago entire country moved above the equator. So, this is the stage of the splitting up of India from Africa and joining with the Eurasian plate. Now, just let me explain one thing with this slide only, with this picture. You can see that this is the part of India. It is not got attached. So, when this was a part, what is the resultant? You can see this blue color. This part was filled up by the water, and it was named as Tethys Sea. It was named as Tethys. It was named as Tethys. It was named as Tethys. Now, Tethys means, sea means sedimentation. So, when continuously that Indian plate was moving towards north and Eurasian plate is just coming down to the south, what is the resultant? The compression was going out over here, and the sedimentation part that is being filled up by the Tethys was compressed by both the side. So, the resultant, the Himalayas were formed. In this way, the Himalayas formed. So, now let look up into the features of the peninsular block, and then I will proceed with the next part. Now, let me proceed with the rate of the movement and how the Himalayas, at what rate the Himalayas are increasing their height. Now, Indian plate that is moving towards northeast at a 5 centimeter or 2 inch per year, while the Eurasian plate is moving north at only 2 centimeter per year. Now, this is causing the Eurasian plate to deform and the Indian plate to compress at a rate of 4 millimeters. Now, 0.16 in per year. So, what is the resultant? This is the 4 millimeters, this part, it is basically the rate of the increase of height of Himalaya. The height of Himalayas are increasing with a rate of 4 millimeters per year. Why? Because it is compressing, and the compressing rate in this order, it is increasing the height of that Himalaya. Now, let us proceed to the feature of the peninsular block. Now, before going to the feature, the 3 geological divisions, number 1, the oldest one is the peninsular block, the young one is the Himalayas and the peninsular mountains, and the recent one is the Indo-Ganga Brahmaputra plain. Now, how the peninsular block is formed? Hopefully, the formation is clear, because we got the Gondwana land, and the Gondwana land is only the peninsular block when it got attached with Asia, and it is formed from the 2 igneous rocks, that is gneiss and granite, and its composition is of great complex, that is formed of by a great complex of various types of igneous rocks, basically gneiss and granites. Now, another feature of the peninsular block, it is consisting relics and residual mountain. Now, what is the meaning of the residual? Leftover. Relic means leftover. So why it is being said so that the peninsular blocks are having that relict and the residual mountains? Because the exogenic forces are unable to wear down the entire elevated portion, because they are of complex hard structure formed of gneiss and granites. So the remnant part of the hills, that is in a dome like structure, or it's a small hill like structure or a mound like structure. So that is why it is termed as relicts and residual mountains. And some examples which is there in Rajasthan is Aravalli, present in the eastern and the western Ghats, Nallamali hills, the Javadi hills, the Mahendragali hills, the western Velkonda hills, the Palkonda hills. All these are the examples of the peninsular blocks. Now next, after the peninsular blocks have been formed, they are what? Rigid and stable landmass. But the unstable landmass, the young and the weak and the flexible landmass that form due to the continuous compression of Eurasian and Indian plate, that is Himalayan mountain. So it is young, weak and flexible, and it's tectonic in origin. Now when it is young and flexible and weak, so the landform indicates what are the various landform that has been developed. The gorges, that is eye-shaped valley, rapids are there. All these things I am going to explain it in the next classes. Just go with the that is a feature. It's a gorge or a eye-shaped valley, rapids are there, waterfalls are there, valleys are there. So when these features are there in any of the physiographic division, that is young division, or that is young landform or the youthful landform. So this is related to your Himalayan mountain, that is the second geological division. The third geological division is the Indo-Ganga Brahmaputra plain. Now after the origin of that is Himalayan mountains, after the origin of the Himalayan mountains, what is it? The Himalayan mountains are glaciated, they are glaciated. So when they are glaciated, that means they have given origin to that is perennial rivers, they have given origin to perennial rivers. So the three important perennial rivers that have originated, one is Indus, another one is Ganga, and the third one is Brahmaputra. The third one is Brahmaputra. So when these three rivers originated, they are continuously carrying sediments, and where they are depositing? They are depositing near the foothills. So when the depositions are there in the foothills, what is the resultant? The resultant is that it has developed a plain region of sediments. It has created a plain region of sediments, and these sediments are thickened, and it has termed as alluvial. It is also termed as alluvial sediments, and they are very much, the thick deposition is there, and it is termed as Indo-Ganga Brahmaputra plain. Indo-Ganga Brahmaputra plain, because it is created by the three rivers, that is Indus, Ganga and the Brahmaputra. Now let us see the features of the Indus, Ganga, Brahmaputra plain. As I said, formed by the Indus, Ganga and Brahmaputra, and is a geosyncline depression, that is geosyncline. Geo means earth, syncline means lowland. So it is a low-lying depression, and I use the word foothills. So which attained in the maximum development during the third phase of the Himalayan mountain formation, approximately 64 million years ago. And as I said, the alluvial deposits are there, and the thickness of the alluvial deposits varies from 1000 to 2000 meters. Now this is related to the formation of Indo-Ganga Brahmaputra plain. So hopefully you understood about the three main geological divisions that evolved out due to the continuous interaction of the two main forces. One is endogenic, another one is exogenic, or in short, it is due to the interaction of the three important cycles. First is that is tectonic cycle, second is rock cycle, sorry, second is hydrological cycle, and the third is rock cycle. Altogether we term it as a geological cycle. So in this way our country got its evolution and with its three important geological divisions. Now I have given one question to do as a worksheet. What is the question? Make a comparative study between the three major geological divisions, and you will just write the answer in a tabular form by writing one after the other, by giving the proper basis or criteria of the comparative study. For example, how it is formed. So the first criteria can be the formation. Second, what is the nature, whether it is rigid, whether it is stable, whether it is in that is mode of formation in this way, that is what is its nature. Then what are its feature that is formed. So in this way you will find out the basis or the criteria, and you will write 5 points of comparative study between the three geological divisions of India. Now if you are having any doubts, just without any hesitation clarify it by mentioning it in the comment section, and thank you for following today's class. Have a nice day.